Okay guys, so welcome to our study of trig equations and solutions of trig equations. I've got to emphasize that the solutions are going to be given in radians as opposed to degrees. So please review your work on radian measure and also understand the use or need for radians as opposed to degrees in various areas of trig as well as engineering and mathematics. So good examples over here: circular motion. If you have a look at what I'm trying to actually illustrate by these beautiful animations is periodic motion and the need to study the sine curve, the cos curve, the tan curve, also its derivatives. All right. And in solving trig equations, what are we really seeking? Not just seeking what x equal to or theta equals to, but this is basically describing some physical phenomena. For instance, the rest position of a particle, maybe its velocity at a certain time. If you look at electronics, we look at the voltage, we look at the current. So very, very useful information in terms of solving these trig equations. So on with the program. Let's see how we go about doing these things. Okay, sine x equals to half. They want the general solution. Well, one possible solution is pretty straightforward. If I remind you from school, sine of 30 is a half, but 30, let's not speak of degrees, is pi by 6 radians. So the next thing we look at is, where is sine positive? Sine is positive, if you recall, in the first quadrant and in the second quadrant. So we have two possible branches, that's what I like to call it. So the first branch in the first quadrant would be x equals to pi by 6 plus 2k pi. What's the 2k pi doing there? Why does it feature? Well, the period of the sine graph is actually 360 degrees. Oh, did I just say degrees? Yeah, it's 2 pi radians. So every 2 pi radians, the sine graph repeats itself. Hence, we tag on a 2k pi. What happens in the second quadrant? How do we get to the second quadrant? Second quadrant is pretty straightforward. It's always going to be x equal to pi minus that acute angle, which is at pi by 6 plus 2k pi. And that should be 5 pi by 6 plus 2k pi. And remind us that k is an integer. And hopefully you know what an integer is. And there you have it, general solution. No problems, easy peasy. Let's move on. What is this? Oh, find the general solution if sine x equal to minus a half. Okay. Now the minus sign makes all the difference. So the first question I'm going to ask is, where is sine negative? We know from experience and from what we learned earlier on that sine is negative obviously in the third quadrant, sitting down there, or the fourth quadrant, not or, and the fourth quadrant. So let's look at the case where sine x is positive. I'm using the alpha, and the reason for that is alpha is what I would like to call a reference angle. Now from the previous slide, we know that alpha must be pi by 6. Sine alpha equal to half, so alpha must be pi by 6. Now we look at where sine is negative. So in the third quadrant, not alpha, but x. Go back to the original question. How do we get to the third quadrant? It's always going to be pi plus that alpha we calculated plus 2k pi, the period of the graph. And so that becomes pi plus pi by 6 plus 2k pi, and that's going to be 7 pi by 6 plus 2k pi. Cool. That's pretty straightforward. And if you look at the fourth quadrant, in the fourth quadrant, how do we get there? Well, if we're not using negative angles, then we're going to go x is 2 pi minus alpha plus 2k pi. That is 2 pi minus pi by 6 plus 2k pi. And that's your answer. You can actually simplify that. What is that? 12 pi minus pi over 6. That gives, please check my algebra, is 11 pi over 6 plus 2k pi. And all of this, we know that k is an integer. And that's it. Pretty straightforward. No hassles. Done. Hey, so what have we here? The general solution. Tan of x is 0.5. So straight away have a look at this carefully and ask yourself, in which quadrant is tan negative? No, positive. It's positive. So we know that it must be positive in the first quadrant, which is there, and then of course in the third quadrant out there. So let's have a look very carefully. In your calculators, my goodness, people are addicted to calculators. Tan x equal to 0.5. So for the first quadrant, pretty straightforward. Right neatly, look at that, crazy. X is going to be, now in radians, inverse tan, I think it's in your second function tan in your calculators. Make sure your calculators are in radian mode. I get 0.464 radians. 464 radians, and we've got to add not 2k pi but k pi, and the reason for that is the period for the tan graph is pi radians. In school you'd have referred to that as 180 degrees. So how do we get to the third quadrant? Third quadrant, pretty straightforward. X would be pi plus 0.464, and don't forget plus k pi, whatever that is. And what do we know about k? Well, k is an integer. And that's it. Easy peasy. Nothing difficult. Awesome stuff, guys. Oh, what is this? Cos of 2x equal to root 3 upon 2. Some people get thrown off with the 2x. Not really. It's just like cos theta, right? Equal to root 3 upon 2. It's positive. So where is cos positive? Cos is positive. First quadrant and the third quadrant. That's where our focus should be. Root 3 upon 2. If I remember, special angle. And that should be pi by 3. In school, you'd have called that 30 degrees, right? I know that cos of 30 is root 3 upon 2. So what it says is in the first quadrant, watch this now, guys, slowly. It's not x, but 2x is equal to pi by, not 3. Did I say pi by 3? No, it's pi by 6, which is 30 degrees, plus 2k pi. Please check this. They didn't want 2x, they want x, so we divide throughout by 2, and that's my answer for the first quadrant. How do I get the answer in the second quadrant? In the second quadrant, it's pretty straightforward. Why do I say second quadrant? I say the fourth quadrant. In the fourth quadrant, what I'm going to do now is use a negative angle. So I want you to think about this very carefully. So it'll be 2x, the angle, and instead of saying pi by 6, I'm going to go this way. It's going to be minus pi by 6 plus 2k pi. They don't want 2x, they want x, so we divide throughout by 2, and here are my two solutions. So two pretty straightforward solutions. There, the ones that I've boxed, and of course, k is an integer. And there we have it. Nothing difficult. But just focus on that negative angle as well. You know, we're not accustomed to doing that. And if you look at the way we travel around here, you know, we start off 0 when we go positive in an anti-clockwise direction or negative in a clockwise direction. And we must be comfortable with positive and negative angles. I think that's very, very important. Whoa, what is this. Tan of 3x minus pi by 6 is equal to 1. It's enough to knock some people off their chair. Well, not really. Think about that carefully. What do I have in bracket? That's just the angle. So not to confuse everybody, I always like to say let theta equals to 3x minus pi by 6. So what are we really solving? We are solving tan theta equals to 1. That's so much better. Okay, just like with the other examples, we ask ourselves, where is tan positive? Tan is positive in the first quadrant. It's positive in the third quadrant. So let's look. Tan theta equal to 1. Calculator. Inverse tan of 1. And in the first quadrant, straight away, I can write out the solution. You're going to get theta equal to pi by 4 plus, not 2k pi, but k pi. They didn't give us theta. We set theta to be 3x minus pi by 6. So eventually 3x minus, you see where we're going with this, equals to pi by 4 plus k pi. So 3x is equal to, take the pi by 6 onto the other side. Common denominator there would be a 12, but we're adding it. 4 goes into 12 3 times. 6 goes into 12 2 times, and that's all multiplied by pi plus k pi. Eventually, I get 3x equal to 5 pi by 12 plus k pi. So what would be your final answer? You divide throughout by 3, and you get x. Right? I'm going to allow you to do that. And hopefully you can actually get that. You can read that out. The answer is x is equal to 5 pi by 36 plus k pi over 3. Please check that. So what happens in the third quadrant? Here's a beautiful red. In the third quadrant, we are going to get theta. Let's look at theta. It's going to be, how do we get there? It's pi plus pi by 4. Because it's that angle over there, plus k pi, and that's going to be 5 pi by 4 plus k pi. They didn't give us theta. We said theta equals to 3x minus pi by 6 equals to 5 pi by 4 plus k pi, and then 3x. Please check my algebra. That's 4 goes into 12 3 times. That's 15. Plus another 2 gives me 17 pi, over 12 plus k pi. Remember, they don't want 3x, so divide throughout by 3. You get 17 pi over 36 plus k pi over 3. And that's it, as simple as that. So they can throw you off by saying tan of da-da-da, 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 and all you let is theta equal to da-da-da, da-da-da, and then solve and eventually replace theta with the original, in this case 3x minus pi by 6. You know, I believe there's always a solution. If we put man on the moon, if we believe we put man on the moon, then surely you can solve this very simple trig equation. Yes, believe that you can do it, and you will do it. Aha! Quadratic equations, quadratic power 2 there. You see that? Sine squared theta minus 5 sine theta plus 6 equals 0. This is an obvious one. And there are also ones that are really like masked, or they're sort of hiding in there, and you got to like source them out very quickly. But this one is pretty straightforward. I normally write let k equal to sine theta. Then this equation just becomes k squared minus 5k plus 6 equals to 0. Hey, it's a grade 10 question. Factorize equals to 0. So I got k equal to what? K equal to 3 or k equals to 2? Let's double check that. Yes. They didn't give us k, they gave us sine theta. So sine theta equals to 3 or sine theta equal to 2. Hey, guess what? Wow, no solution here. You know, the amplitude of the sine graph is 1. So in both cases here, no solution, no solution. You know, we train from a very early age. It's always that you present an exam question, you present to an exam question, and there's definitely that value of x, or that definitely that value of theta we've just demonstrated here. Well, the solution to this question is there is no solution. Perfectly acceptable. Cool stuff, man. Whoa. Airbag, protect me from this monster. You know, we talk about quadratic equations and you're thinking, where's the quadratic over here? And I told you they're hidden and they lie in wait for you. And you've got to be smart enough to check it out carefully and say, aha, have a look here. 2x, x. Now cos 2x, double angle. So we know we can write this as 2 into cos squared x minus sine squared x, then minus sine x minus 1 equals to 0. And now you're looking at this and saying, okay, but you know, there's a sine x here, and there's cos squared. Why don't I write everything in terms of sine squared x? Let's have a look. So cos squared, remember, is 1 minus sine squared x. There's the other. Do this slowly. I mean, students always rush. What are you rushing for? There's no bus waiting for you at the end of this exam or this course. So let's simplify that very carefully. Multiply that out. Minus minus, it becomes minus. So it becomes minus 4 sine squared x minus sine x minus 1. Watch the algebra here. So it's minus 4 sine squared x minus sine x. And what is 2 minus 1? 2 minus 1 in my life is 1. Multiply throughout by a minus sign. You get 4 sine squared x plus sine x minus 1 equals to 0. Haha! And this is exactly the problem that we looked at previously. The form is the same. And so what do I mean by that? Well, if I let k equal to sine x, then this problem now transforms to 4k squared plus k minus 1 equals to 0. 4k squared plus k minus 1, can that be factorized in such a way so as to give you the center term as being k? Not too sure, then you are forced to use the quadratic formula, and that's beautiful. So that's minus b, which is minus 1, plus or minus square root of b squared, which is 1, squared is 1, minus 4ac. Please check this out. So minus and minus, that becomes minus 4, that becomes plus 16, all over 2a, which is 2 times 4, which is 8. So we've got k is equal to minus 1 plus or minus root 17. That's interesting. K is equal to minus 1 plus or minus root of 17 all over 8. A beautiful question. You would use your calculator and then you would simplify and you'll get K. Remember, the question did not give us K. They gave us sine of x. And once you got those two roots, you let sine x equal to those constants and bang! You shall produce the solution. Let's take a closer look in the next slide. Okay, so recall previous slide. Let's just go k equals to sine x. Remember, that's the transformation we put in there, and we managed to, after playing around with the quadratic formula, we managed to show that k was minus 1 plus or minus root of 17 over 8. So that's basically telling us that sine x is equal to minus 1 plus root of 17 all over 8, or sine x is equal to minus 1 minus root of 17 all over 8. Now let's have a look at that and see. So the first one is the square root. Yeah, we got 17. And then we're going to subtract 1 from that and then divide by 8. So we got sine x is roughly 0.39. And the other one is we've got sine x equals to, so yeah. And then divide that by 8 and we got minus 0.64. So think about this carefully. So now we've got two branches let me just divide this up so you get to understand what I'm saying here. Each of these, the left-hand side is going to give rise to two branches, you see, because if you look carefully in this part, sine is positive where? In the first quadrant and then in the second. To the right of me, that's interesting, in this branch here, sine is negative. Which quadrant is sine negative? It's in quadrant 3 and quadrant 4. So essentially what we have here are 4 solutions. I'll give you an idea very quickly. The first solution, 0.39. So you go inverse sine of 0.39, and that's going to give me an answer in radians. So in the first quadrant, x is going to be 0,4 radians plus 2k pi. And then in the second quadrant, you got to write neatly. X is going to be pi minus 0,4 radians plus 2k pi. There you are. Two solutions for sine x equal to 0.39. What happens in this case where sine x is equal to minus 0.64? Of course, you do exactly the same thing, but you would now have, let's work with negative angles there. So the first one is, if you look in the fourth quadrant, you'd have sine being negative. So you're going to use the angle in radians. Or what we can do is introduce a reference angle. So you go inverse sine of 0.64. That angle turns out to be 0,695 or 0.70. So in this case, in the third quadrant, how do we get to the third quadrant? It's going to be pi plus the angle, which turns out to be 0.70 plus 2k pi. In the fourth quadrant, how do we get that? Please check. It's 2 pi minus 0.70 plus 2k pi. So that will give me minus 0.64 as sine x. 4 branches of these solutions covering all 4 quadrants. Please check my algebra. If there's any mistakes, it's deliberate, and that is for me checking whether you're awake or not. So please work through this. The problem with students is when you have access to solutions like a solution manual or video that shows you how to do things, then what you automatically assume is you can do it without actually sitting down and working through the problem. Oh, I would have done that. Oh, I could. No, you wouldn't have if you didn't have the solutions. So sit down with no solutions, start from first principles as if you're writing a test or exam, get your answer, and then compare your answer to mine or the solution manual. Cool stuff, man. Okay, what is this? Well, let's look at a general form of a linear trig equation. A cos x plus b sine x equals to c. In school, you basically looked at early stages in your life. You looked at special cases where c was 0, for instance, or b was 0, or if b was not 0, then you had the case of b sine x equal to a constant, or a cos x equal to a constant, or you had something like a cos x plus b sine x equals to 0. But what if a, b, and c, which are just numbers, are all not 0? How do you solve such an equation? Can it be solved, And the answer is yes. And there's a beautiful little transformation that we introduce, and that makes this form of the equation pretty straightforward to solve. So that's what I'm going to take you through, do a few examples, and tidy up at the end. And I think you'll appreciate this method. Very popular one in the exams as well. So let's have a closer look. Okay, so what if, in general, you had a cos x plus b sine x equals to c? How would you solve this? Now, it's interesting. If I look at the left-hand side, and if I plot that, if I know what a and b are, and I take several values of x, this left-hand side actually behaves sinusoidally. That's a nice word. So in other words, I can write it as some constant r times sine, say, of x plus an angle alpha. Okay, the alpha is actually referred to as the phase shift. So I can do that. I can write a cos x plus b sine x as r sine of x plus alpha, where I've introduced a new constant r and another constant alpha. Now take a closer look here. I'm just doing this in general so you'd appreciate what I'm doing. So what is the right-hand side equal to? The right-hand side, if I break this up, because it's a compound angle, right? It's r sine x cos alpha. I'm using sine of a plus b, which is sine a cos b plus cos a sine b. So there's my plus there. Don't forget, I'm going to multiply the r into that. And this becomes cos x sine alpha. Now remember, alpha is a constant, so sine alpha, cos alpha are constants. In fact, this is radian identity, so it's true for all x. So have a look here. The coefficient of cos x on the left-hand side is a. The coefficient of cos x on the right-hand side is r sine alpha. Similarly, if I look at the coefficient of sine x on the left-hand side, it's b. And the coefficient of sine x on the right-hand side is r cos alpha. And if you look carefully here, what do I have? I have two equations, equation 1 and I have equation 2, with two unknowns. Remember, a and b are just numbers. I know these. But the unknowns are r and alpha. So what if I squared both sides of equation 1 and I squared both sides of equation 2? What will I get? Well, equation 1 will give me a squared equals to r squared sine squared alpha. Equation 2 will give me b squared is equal to r squared cos squared alpha. And if I had to add these guys up, with no stretch of the imagination, you will tell me that r squared is a squared plus b squared. I want you to think about it carefully. Don't rush through it, but that's basically it. So r is the square root of a squared plus b squared. So if I know what little a is and if I know what little b is, bang, I've got capital R, which is the constant I introduced. How do I find alpha? Well, look at equation 1 and 2. If I take equation 1 and divide that by equation 2, for sure as God made little apples, equation 1 divided by equation 2 will tell me that tan alpha is equal to a over b. And now I've got alpha because I know what a and b are. And that's it. So what I've taken, and you need to appreciate, this is a very powerful method. I've taken this very complicated equation, a cos x plus b sine x equal to c, and I've transformed it. And what I'm really solving now is r sine of x plus alpha equals to c, which is a much simpler equation to solve. That's basically what we've been doing in the early slides, say slides 1 to 5 of this lecture or lesson, not even a lecture, a lesson. So cool stuff, guys. So let's try to apply what's on this slide to some problems. The best way of learning mathematics is to do math, not to read math. And there's a big difference. Okay, so let's get on with this. Okay, so here's a simple example. I'm going to go 3 cos x plus 4 sine x equals to 5. That's the other thing that's important. Write the equation in standard form. A cos x plus b sine x equals to c, a constant. So that's in standard form. We know straight away, you know, r is the square root of the coefficient of cos x squared plus the coefficient of sine x squared. We already know that. So that turns out 3 squared at 16. So r turns out to be root of 25. And it's going to be plus 5. We're going to take the positive root. So we got r equal to plus 5. Now, what about the angle alpha? Because what I want to do, think about this carefully, suddenly asking me where's r coming from, is to write the left-hand side, this guy, 3 cos x, I'm going to do this slowly, plus 4 sine x is r into, well, not into, so maybe I should write this as r sine of x plus alpha. And what I did in the previous slide was very slowly split this up, plus r cos x. I'm just doing this slowly so you can understand and appreciate what I'm doing. And then I compared coefficients. Coefficient of cos x, coefficient of cos x. So this tells me that 3 must equal to, this 3 must equal to r sine alpha. And if I compare the other one, the coefficients here, sine x, so 4 equals to r cos alpha. Sorry, here I meant for this to be an x, and you would have spotted that if you were awake. Yes. So you can see straight away that if I square both equations and add them, I will get r equal to 5. And if I take equation 1, say, and I divide by equation 2, then that will tell me that tan of alpha, sine over cos, r's will cancel out, is 3 over 4. So I'm going to show you very quickly. So second function, make sure your calculator now is in radian mode. Mark tan, or second function tan, of 0.75, which is 3/4. So it tells me that alpha is 0.64. And this would be in radians. All right. So this very complicated problem, which is in this very first line up here, this line, has now been reduced to the following. Watch this and learn to appreciate what we've done here. The left-hand side now reads as 5 sine of x plus 0.64, and the right-hand side is 5. So pretty straightforward, isn't it? The 5s will cancel out. And what we're solving for, look at this, guys. This is amazing. You should get goosebumps and goosebumps here. We are solving sine of x plus 0.64 equals to 1. And come on, we all know how to solve sine of x plus 0.64 equals to 1. We know that's going to be pi by 2. So that's going to be x plus 0.64 equals to pi by 2 plus 2k pi. So finally, what is x? Pi by 2 minus 0.64 plus 2k pi. Now, I want you to think about this very carefully. If sine x is equal to 1, do you have 2 branches of solution? You see, I'm given 1 branch here, and this is at pi by 2. If you draw this very carefully, you're going to have something there. Where is pi by 2? Pi by 2 sits right over here. That's pi by 2. So do you have a second branch where that is positive? Or is there only one branch of the solution which gives you a pi by 2 plus 2k pi? Will that cover all the solutions? Think about that very carefully. That's your homework, by the way. But what I'm interested in right now is the method. You know, you're given this complicated, almost vicious beast of a question. You do a transformation. It comes down to this beautiful, elegant form. And you can just read off the answer. I think that transformation is important, that you understand it. You don't really have to take every step. But what I like to do is do things slowly. It makes sense to me, and I understand it. In the exams and tests, you're not going to get 100 questions like this. You're going to get 1. Do it properly and get it right. Okay, cool stuff, man. Okay, so while I'm sitting here in the dark trying to rub two sticks together to produce electricity, or fire for that matter, because of load shedding, I thought let's do another example. And I'm not going to tell you I'm powering. How am I powering this laptop? I'm using something called dark energy. Anyway, so we're going to look at 2 cos theta minus 3 sine theta equals to 6. Now let's just do this very slowly as if we've not seen this before. And I'm going to look at the left hand side. There's a minus sign there, so I'm prompted to say let's try this out. Equals to r sine of, instead of a plus, let's put a minus. Theta minus alpha, where r and alpha are just constants. So what I'm going to do is now take this guy and split it up into sine theta cos alpha minus, yes, cos alpha sine theta. How can we do that? R sine theta cos alpha minus r cos theta. It's exactly what students do. They just confuse everything. Okay, so there we go. Now we're going to look at the coefficients. Coefficient of cos theta is there. Coefficient of cos theta there. So 2 must equal 2 minus r, watch, minus r sine alpha. And then if I look at sine theta, coefficient is minus 3. Sine theta is r cos alpha. And see, straight away, whatever you do, square both sides, you're always going to get r equals to 2 squared plus minus 3 squared, the coefficients. So what is r equal to? That's 9 and 4, so r is root 13. Don't always look for nice numbers. Well, root 13 is a nice number. How do we work out alpha? How do we work out alpha? Now this is interesting. So we got sine alpha over cos alpha. If I call that equation 1, call that equation 2, 1 over 2. So watch this, minus r and r cancel out, so you're going to get minus tan alpha is equal to minus 2/3. So we're going to get tan alpha is equal to plus 2 over 3. Watch the minus signs go away. And if I work this out, alpha, what will that be? Make sure your calculator is in radian mode. And that's 0.67 for 2/3. Is that right? 0.67, and it turns out to be 0.59 radians. So what? You know, sometimes we do all of this and suddenly realize, where are we? It's like getting into a car, driving for 100 kilometers per hour, 100 kilometers, and then realizing, where am I going? All right, so you do these fantastic things and suddenly you forget what you're really solving for. Well, what we're solving for is theta. So that original question can now be written in this beautiful form. What is r? R was root 13. And we said sine, be careful, theta minus, there's the minus there, 0,59 equals to 6. And then sine of theta minus 0.59 equals to 6 over root 13. And if we want to work out, now watch this, guys. This is positive, yeah? So where is sine positive? Sine is positive. Let's draw this for you very quickly. It's amazing how the things you learned way back in primary school, you still have to apply here. It's positive in the first quadrant, it's positive in the second quadrant. So it's telling me this whole angle, theta minus 0,59, must be, let's have a look. So we're going to go 6 divided by the square root of 13, which is 1.666. How is that possible? 6 over root 13 cannot be that. 6 divided by, yeah. Oh, my calculator. I've never owned one, so that's the reason why I am struggling. It doesn't work. It doesn't work because 6 over root 13 actually had that right. And 6 over root 13 is greater than 1, and if it's greater than 1, hence no solution. Please check that out. That's awesome. Okay, I love these because you don't have to go any further than that. So the fact that you got sine theta minus 0.59 is equal to 6 over root 13, which is greater than 1. Hence, you can proceed no further, no solution. That's it. Stop over there. Cool stuff indeed, man. Absolutely cool stuff. That's interesting. Okay, let's try something else. I want to try something else here. I'm going to give you something like 3 cos x, something similar to what we've seen before. 4 sine x equals to 5. In fact, we actually solved this problem before. Hopefully you recall that. But what I want to do now is something interesting, because we have the freedom, right, to choosing the way we write this. So what if I choose to write the left-hand side as 3 cos x plus 4 sine x equals to r into cos of x plus alpha? Will I get the same answer? How do I know when to choose cos or when do I choose sine, whether it's x plus alpha, x minus alpha? Oh my goodness, so many choices. So it's r cos x, cos, isn't it? Cos alpha minus sine change, r sine x, sine alpha. Just like before, we compare coefficients. So the coefficient of cos x, coefficient of cos x. So I get 3 equals to r cos alpha. And the other case is sine x, sine x. So I get 4 equals to, now watch this, minus r sine alpha. Just as before, r is equal to the square root of 3 squared plus 4 squared. Right? We're always going to get, and that's root of 25, which is, we're going to take the plus root, so it's going to be positive 5. Now here you've got to be very, very careful. If you look carefully here, yeah, I can divide one by the other. And if I do, let's call that equation 1. Let's call that equation 2. So equation 1, equation 2, if I take 2 divided by 1, what do I get? I'll get tan alpha, and that is minus 4 over 3. How do I deal with that minus sign? Tan alpha is minus 4 over 3. Tan is negative in the second quadrant and the fourth quadrant. So how do I determine which quadrant we're working with? Aha! But think about this carefully now. And this is very useful. Just going to point this out. So we know this tan alpha is negative in the second and the fourth. So we got to decide which one are we working with. Is it the second or the fourth quadrant? And then you realize here that cos alpha is positive. Now cos alpha is positive in the fourth quadrant. And sine alpha is negative here. So sine alpha is negative in the fourth quadrant. So tan alpha equal to minus 4 over 3, while it selects this guy and that guy. Equation 1 and 2 tells me that alpha has to be in the fourth quadrant. So we have to use tan alpha equal to minus 4 over 3 as if it was in the fourth quadrant. And minus 4 over 3, so that'll just be arctan of minus 1.333, if I think about that. And we work with negative angles, so the angle turns out to be minus 0.93. Please check that, minus 0.93. Make sure you also understand why we're not using the second quadrant. We are using the fourth quadrant because of equations 1 and 2. And so what are we solving for? Well, we are solving for this thing. The original equation can now be written as r was 5 cos x minus 0.93 equals to 5. 5 goes away, so we got cos of x minus 0, 93 equal to, is that 1? Yeah, that's 1. And cos of what is 1? Well, you realize that x minus 0, 93 is 0 plus 2k pi, and we should be able to solve for x straight away from there. No complaints whatsoever, and out pops the answer beautifully. So we can choose to write the left hand side as a cos function, a sine function. Whether it's a plus b or a minus b doesn't really matter. We will always get the transformation to work, and hence in that process determine the solution that's required from us. That's pretty awesome, man. That's pretty cool stuff indeed. Love it. Okay, so here's some food for thought, something to keep you awake. To keep you awake at night, to both eyes open. How do we solve 1? Cos of 3x equals to cos of x. 2. Sine of a equals to sine of b. General solutions for these two. That's the whole point, isn't it? You've got to be a bit uneasy with things, and when you're uneasy about things, then you focus on stuff. When you get too comfortable, then you tend to forget stuff. So some homework here. Please phone a friend, WhatsApp a friend, post this on Instagram, Facebook, take selfies with this, make these problems famous, and I will address them in my next video. See you on the other side of 10, whatever that means, and good luck with load shedding. And remember, darkness is just the absence of photons, which have energy E is equal to hf or hc over lambda, if you believe Einstein. Cool stuff, man.